To forecast time series in Python, we need to fit a line or a polynomial, exponential, logarithmic, some type of trend, see how well it fits and predicts into the future. To do this in Python, we're working through a Python workbook. You can work along with us. So go to drstephpowers.github.io/mgmt-in-python. So mgmt-in-python. And we're working through the workbook called Forecasting that you can click on right here. It will open up in GitHub. You want to click on the link to Google Colab. Open up in Google Colab. And so that you can edit your own version, you'll need to sign into your own Google Docs here and copy to your drive. This allows you then to change the code and save a copy for yourself. If you're turning in material for my course, make sure that any work you do, you're saving so that when you submit links or files that your work has been saved to that. All right, so I'm just going to switch over to the one I'm logged into. And we're looking at these trend forecasting methods. Our previous video looked at the short-term methods. So let's do some trend forecasting. We want to plot this information, so we're going to do import matplotlib.pyplot as PLT. So we need that package for our plot, for our graphing. And we're going to use a couple different trends, and we'll start with the linear regression. So from sklearn.linear_model, import linear regression. And because we need to manipulate the data to make the regression model formatted the way it wants it, we need to import NumPy as NP. So we will import our packages here. And then the next thing we want to do is to import our data. So in this case, we've been looking at the number of complaints at our business, and we have here entered in the complaints, and we'll just call that C for complaints. And so you can see that's just a list of numbers, and we have the corresponding periods, 1, 2, 3, 4, 5, 6, 7, 8. To make it easy to look at, we can turn it into a table. And that table will show our period and our complaints. And so to get it into a table form, we use pandas. That's the PD part of this command here. And we're using a data frame. And then the way that we're formatting the data frame is we use something called list zip. And this allows for us to specify the data in terms of columns. So we gave it C, we gave it period. Now we say, okay, create a table where we have our column of period information, our column of complaints, and then we gave the columns names. That's the columns equals and the quotes for period and quotes for complaints. So it creates this table here of data that we can then graph and find or fit a line to. So in order to find our linear regression for our data, we need to reformat it. So whatever you're putting on the x-axis in terms of your graph that you're going to find your line of best fit for, we need to turn into an array and we need to reshape. So here we'll just call it x and y. So x will be the period. And so we're taking it from the complaint table, that's CT. We're taking a column called period. We are going to turn it into an array using NumPy, and we're going to reshape it so that it matches the way the linear regression model fits. Okay? So really, if you're using this for your data set, all you need to do is sub in whatever time period you're using, whatever the table is of your data, goes right there. And then we have our y values. What are we trying to predict? Here we're trying to predict the number of complaints. And so we take from our complaint table, that's the CT, the column called complaints, and we need to convert it into an array as well. So we're formatting the data so that it can do its line of best fit. If you're doing this for your own data set, simply swap out the CT complaints with your data, and then we can just for now call them X and Y. We're then going to do linear regression. We're going to start by fitting a line. And we call the model. It's a linear regression. We fit the X first and then the Y. Okay. And then what we want is a formula for our line of best fit, and we of course want to graph it as well. So we can use the command, we called it model, so we can, from the model, give us the coefficients, and you can have it call it something. You know, previously I called it B, but you can also just have it pull the information. Okay. And this is going to be our slope of the line. And then we have here our intercept. So we could call it A, or you could just simply say from the model, provide me the intercept. And when you do that, you get a number here. Well, what is all of this telling us? What this is telling us is that our forecast model is 52.357 plus 3.64 times X. Okay, so what is that saying? That's saying the number of complaints at period 0 is 52, and then as time progresses, the complaints go up. And they go up by 3.64 for each period. Okay, we're getting that here from the slope and the intercept. How well does this model actually fit? We can use what's called an R-squared, coefficient of determination, and that tells us how much of the variability in X can explain the variability in Y. To do that, we have created this model. We called it model. And so we can just simply have it give us the score that goes with that model. So model.score, and then give us as X and Y relate to each other. So we get a R-squared of 0.63. So 63% of the variation in X explains the variation in Y. The higher the R-squared, the better. However, to get a perfect R-squared, you might have a super complicated model, which is hard to explain, which really is not indicative of what the future looks like. Remember, the R-squared is based on historical data. It doesn't tell you anything about the future. So you can have a model, and we'll look at it in just a moment, that has a really high R-squared, but is a terrible model for the future because while it's matched every movement of the data in the past, it doesn't actually explain what's going to happen in the future. Typically, we're looking for an R-squared about 80%. That means that it's high enough to fit the data well without overly complicating it. This one is 63%, not bad. So let's predict some values. So we already have that linear regression model. We can use model.predict to predict some X values. And we're going to call those predicted values Y sub P. So they are Y values that were predicted. And we do that so that we can actually plot them along with the actual values later. So we're going to do Y sub P equals model.predict X. This predicts the values for the actual X's we already gave it. But we also want to have it predict values for new X's. So we looked at here our complaints, periods 1 through 8. What about the future? What does it predict for periods 9, 10, and 11? So to find that, what we do is we say, okay, well, let's call it X2. X2 is an array that includes the numbers 9, 10, and 11. And because we're loading it back into that linear regression model, anything that's an X value has to have that reshape. So you're adjusting the way it's formatted in order to make the model happy. So our X2 is going to be an array, it's going to be reshaped, and we're just specifying what those new numbers are. So we're trying to predict periods 9, 10, 11. We've gone forward 3 periods. You could go forward more if you wanted to. When you are doing your forecasting models, you of course need to decide how far back into the future you need to go. Bigger is better. General rule of thumb is to go back 20 periods if you can. At minimum, you need to go back further than you're going forward. So here we're going back 8 periods. We're going forward 3. Okay. All right. So we're going to give it the new X2 values and then have it predict the Y's based on those new X2s. So it's saying that in periods 9, 10, 11, the number of complaints are 85, 88.7, and 92. Whereas in period 8, it was at 83. So you can see how it's going up, and you can see that it's up in the 80s and 90s because that's what it was in the previous periods. To help us really kind of visualize all the things that we've just created, we want to plot the information. So we're going to use that matplotlib. We're going to plot our x and our y. That's our original data. And let's have it just be dots. So line style equals none, and then the marker equals the quotes around the O there so that we can have it be dots. Then let's have it plot the predicted values of y. So that's our y sub p, given the actual x values. So given the periods, what should the model say that the y's be? This is your line that you've created. Let's make it nice and thick. Lin width equals 2. Then let's also plot our new x values, so that additional 3 periods, period 9, 10, 11, and their corresponding y values that come out of the model. So let's have them be dots, but let's also connect them with a dashed line. Let's label the x-axis period, the y label complaints, and we can plot this. If you want to have grid lines, because that makes you feel better to see what's going on, you can do plt.grid as well. If that makes it too busy, you can pull them out. So what we see here is the blue dots are the original data. That's the complaints for those first 8 periods. The orange line that we see here is the forecasted model. That's your line of best fit that had the 63% R squared. And then you can see here, based on that line of best fit, it is predicting forward into the future, period 9, 10, 11, that it continues to increase. Okay. So we have fitted a linear model to our data, and we have forecasted 3 points into the future. We've also found a formula for forecasting even further into the future should we want to. Now, when we look at this, we said it fits 63% of the variation in the periods, explain the variation in the complaints. Notice here there's some kind of strange pattern where it's above the line, below the line, and then back above the line. This indicates there might be some kind of seasonality, some kind of cycle to the data. If it's a bunch above, a bunch below, and then a bunch above again. To help us see if we might need to accommodate for that variability by putting a cycle into our forecast, we can plot what are called the residuals. The residuals are the difference between the actual complaint and the predicted complaint. So how far is the dot from the line? How far is this dot from the line? How far is this dot from the line? So we do residuals equals y minus y sub p, and we can plot that information. So we do plt.plot, and we're plotting the periods, the x's, and then we're plotting the residuals. Here we're going to have no lines, just markers, and then we can add in this horizontal line at 0. So this helps us to see if there's a trend in what's left over after you add your linear model. So I'm going to run this here. Essentially what you're doing is you're taking this line here and you're flattening it, and then you can see the difference. So you can see this group above, this group below, this group above. And so you can see that there might be some kind of cycle here where it's high, then low, then high, in which case we might want to add some kind of seasonality. Maybe the complaints are tied to day of the week or month of the year. So maybe there's something else that explains why complaints are high and why complaints are low. Adding seasonality to these forecasts is beyond the scope of the operations management course. We will look at how to do seasonality into your forecasts in the business intelligence and analytics course, or if you are doing the statistical analyst micro-credential at Red Deer Polytechnic.